good to go?
You're good to go.
Okay.
Thank you.
So this is, I know that the title looks a little different than what was out there by like a few letters, but I got creative and decided to just say auth instead of authentication because this isn't just about authentication. So just so you know, you're in the right place. It's a pun, API, poorly implemented. I'm Zach Lanier. I work for Accuvant Labs. I'll have that in intro thingy. So this is actually my first time doing this talk, which I just finished like 10 minutes ago, because that's how it works. So basically, we'll talk a little bit about what this talk is about, and then kind of just dive right into issues and examples. And then a couple solutions, not really something that's like prescriptive or anything, but something that you could at least explore yourself, and could maybe use in your day-to-day work. And then a conclusion that really doesn't answer anything. So about me, I'm senior research scientist, which is a really fancy title, in the applied research team in Accuvant Labs R&D team. So basically applied research is the consulting branch of R&D. So scientist makes me sound like I know more than I actually do. I used to work at Duo Security, and before that I worked at Accuvant. So this is my second tour of duty with Accuvant. This talk came out of some stuff that happened at Duo. If you're not familiar with them, they do two-factor auth stuff, so that's what spurred this. Old net web mobile pen tester type, and shameless plug, I co-authored a book that came out in April about Android and got pirated numerous times. That's not a good thing. So about this talk, we're just going to discuss some common issues, at least ones that I've observed or have observed by proxy around authentication, authorization, security in APIs, specifically web service APIs. They don't necessarily have to be issues that are directly related to authentication or authorization security, but it could be something that, you know, an underlying issue that gave rise to one of those issues. So like I said, some of these are mine, some of them were discovered and disclosed by others. Credit is given where due. It's certainly not an exhaustive list of issues or of examples or solutions. So I'm not going to make you like API hacksaw when you walk out of here. Obligatory disclaimer, you already know what that is. So we'll just jump right in, and feel free to stop me if you have any questions. Otherwise, I'll try to keep pace with the time slot. So legacy API integration, this is sort of a loaded term, but things like SOAP APIs, XML RPC, not fancy, shiny Web 7.0 RESTful things. With the chopped off part of it there. When trying to get these to play nicely with the 2.0 API, the nice RESTful one, oftentimes you might have completely different development teams who worked on the old thing versus the people who are working on the new thing, and then trying to get those to like have nice synergy with authorization and authentication mechanisms. That doesn't always happen very well, so you end up with inconsistent enforcement of logins, you end up with inconsistent enforcement of authorizations and entitlements. You might have inadequate support for current standards. You might have one API that uses something like OAuth, that's the nice shiny RESTful one, and then the other one uses some token out of, you know, some exchange that happens in that initial authentication that's then uses an authorization token for this other API. So is anyone here from PayPal? Good. Good. So this has apparently happened a few times with PayPal. They have this thing called security key. It's their two-factor auth. Apparently, no one really uses it anymore. There was a 2FA bypass, second-factor authentication, by the way, discovered and reported by Daniel Saltman in March of last year. And I'll spare you all the disclosure details, but it came to as a friend of the company, when I was at Duo, Dan passed off some of this information so that we could help him refine this and kind of do some root cause analysis that PayPal themselves failed to do. And it was basically due to a discrepancy between this RESTful 2.0, like their API 2.0, and their legacy SOAP-based transaction API, mobile transaction API, that was really not supposed to be used by developers. you could basically just use primary credentials to conduct transactions. So even if it was a 2FA-enabled account, simply getting someone's username and password from one of the millions of dumps was sufficient to send all the money. So even an example here, you see the screenshot. This is like if you tried to log in from the iOS app, you get like the, are you using a security key? Sorry, our app doesn't support that. It's funny how Dan actually found this. He saw this error and he realized that he flipped airplane mode on right after he started to see his account screen. It would error out, but then when he disabled airplane mode, he was logged into his account. So primary auth was sufficient. Just some like little technical blips right here. Redacted heavily, well not that heavily, but this was like the initial authentication to their OAuth 2 endpoint, and in the response, I get this like JSON dictionary back, and you see here that my account is in fact 2FA enabled, and then you see here this session token, and that's the session token that's then used to send all the money. So that was enough information to then just start talk to this legacy API and do all the things. So it's pretty cool. Pretty proud of that one. This is kind of obvious, but like bug inheritance, and people probably have different terms for this. Shared attack surface, things like that. This is really super obvious, but underlying or backend components, libraries, think of all the numerous OpenSSL issues that have cropped up and how those have bubbled up through other services and applications. So basically anything that you're building on, if it sucks, then your app and API suck. So an example here would be MySQL had this typecasting issue, basically in the way that it compared integers and strings across different columns. I don't know how to pronounce his name from Vinolit, but Jornchen in Feb of 2013 disclosed this, and it actually, the practical example of this is that it allowed for an authentication bypass in the GitHub API for certain users of an organization. So this is real nice, like select 1, 2, 3 from some column where 1 equals a string, and it's like nothing. Select the same thing where 0 equals a string. Oh, yeah, here's the result. So, yeah, as FX from Vinolit said, go home, MySQL, you're drunk. Client-side enforcement. This is not obviously unique to API security, but it's very common in mobile, and mobile apps, I don't know, occasionally talk to APIs or some sort of web service, like once in a blue moon. So if you're not familiar with this, this is basically any sort of enforcement or control of a process or some sort of significant element, like an identifier or a counter being set or dictated solely on the client and the server implicitly trusting that no one did a bad thing with it. This is obviously not news to most of you, but it is, another thing might be client-side enforcement of a logout. Or termination of a session against a given service or API. That's like OWASP 101 type stuff. But an example, my buddy Mark Stanislav discovered and reported this in December of 2013. We didn't really talk about who the vendor was the first few times we talked about this issue, but statute of limitations. So basically the way that this worked, this toy, called Toy Mail, would have, you could buy these credits, so you could send they call them stamps, so that you could send messages to these various devices, so that it would cost you a stamp every time you did it. So this was all done from in-app purchasing. But the client would tell the server how many credits it had. So you could have, you could say, like up here we have, I just checked how many stamps did I have, and I have 105 stamps. Well, you know what? Now I want a bajillion stamps. So I tell the server I have a bajillion stamps, and the server goes, okay, you have a bajillion stamps. So economic denial of service on there. They're like 99 cents for 1,000 of them or something. But obviously that's not a good thing to rely solely on a client to tell the API what is okay. Any questions so far? I'm kind of blazing through these. This is going swimmingly. Information exposure. These are all very generic titles, I know. In case you don't know what that means, in the case where a response from the API gives you more information than is absolutely necessary, it could be sensitive session or state information, internal URIs, very OWASP 101 type things. The PayPal thing is probably another example of that, where that session ID coming back was sufficient to then talk to this other very sensitive API. Obviously, a lot of this is used then to facilitate privilege escalation, or, I don't know, stealing money from people. Again, using Toymail as another example. Mark also found that there was this, it's a little bit of a workflow breakdown, but also an information exposure issue, where the way that the workflow is supposed to work is you ask to be a friend, or you send a request to a child, and their parent or guardian says, yes, it's okay, before you can start sending messages to this device. Well, in the response to the initial friend request has all the information necessary to then talk directly to the device. So even if the parent says, no, that's not okay, you can still then just start sending messages to the target device. So obviously, that's not smart. So this is the response. It's JSON dictionary inside of the ID, and then like the email associated with the target account. It has all these things about like if they're registered or not. But yeah, that's enough information to then talk to a child. That is creepy. So obviously the UI would actually not display this, the actual mobile app, but obviously don't transmit that back if once it hits the wire, like it's out of your control. This is also really dumb. Insecure communications. What does that mean? It's where you don't use encryption. Yes, obviously this still happens. So this isn't unique to API auth security. It applies everywhere. In the days of Prism-like things, this is probably important. So it could be complete lack of any sort of protection of TLS and SSL, or people still rolling their own crypto, or having falling back to plain text after a failure, or someone doing like SSL strip, and you still happen to support unencrypted communications with whatever endpoint it is. So this is kind of a slightly convoluted example, but the IZON, is anyone familiar with IZON IP cameras? So like Dropcam or Piper, one of those, like IP-enabled camera, and the IoT. Calls between the device, the app, etc., to any third-party API that was in use was all done without SSL or TLS. And to add insult to injury, your IZON account password was an MD5 sum and transmitted in plain text. So go to Starbucks, wait till someone is checking their video camera, extract their password, and crack it if you can, because MD5 is pretty strong. So yeah, and then you get like De Niro watching you, which is pretty cool. So alternate paths and channels. This was one that I also thought was kind of cool. One of the few, I should say. So there's like a CWE for that, so that's kind of neat. Basically exercising any sort of alternate code path that wasn't considered might allow you to sidestep some sort of check, right? Maybe unintentionally or deliberately. So maybe hitting a different login form in the same application might circumvent some sort of entitlement check or something. In this case, the example was this WordPress plugin API. If you're probably familiar with this, WordPress has plugins. So there are these hooks around authentication and authorization, and you can basically shim yourself in to do additional checks, such as second factor of auth. So what happened was Omar Abdul-Jabbar, who I worked with at Duo, and was responsible for maintaining the WordPress integration, amongst other things, discovered that if a user, an organization had used the multi-site feature of WordPress, which if you're not familiar with that, it allows you to have like one WordPress installation with a master site and then all these like kind of child sites, but they're all effectively part of the same WordPress installation. So if you had an account on site A, and actually I have a really nice flowchart that I made for a blog post. So Alice browses to site 1 blog. She's presented with her primary auth prompt. She provides primary credentials. Did she pass? Yes. She gets second factor. She does whatever she has to do to go to second factor, and she's logged into site 1. Bob is also a member of site 1. He browses to site 2 blog, which is part of that same installation, where he is not a user in that site, but because he's part of the master site or one of the sibling sites, his primary credentials are valid. So he passes primary auth, he gets redirected to site 1 and he's logged in. So the problem was that the underlying issue is that in multi-site deployments, the plugin API didn't present a way to directly track any sort of second factor or hooked auth routine. So it was a kind of a hack to get it to like update these, like set a new cookie value and like constantly compare that with every step. So it's really kind of funky, but that is an alternate path. I think it was kind of cool. And it affected pretty much anyone who had a WordPress second factor auth plugin. This is not rocket science. Staff and shared credentials. Obviously, any application that hard codes credentials in, perhaps for support purposes, or an API, to talk to an API or something, that would be awful. Any application that uses the same credentials to authenticate to an API or a key, API key that can be extracted and is consistent across every transaction, is bad. So shared API keys like Flickr, Google Maps, etc. They all have, those are used, to like kind of measure quotas, identify a particular developer, things of that nature. So there's this Moonpig API. I didn't even know what Moonpig was until this disclosed in January 15th, so I didn't know what it was until this month. Paul Price reported this in August 2013, and it was never really fixed, so disclosed it in January this year. Basically, as it turns out, although it was done over TLS, every API request was authenticated solely with a basic auth header, the same credentials for every transaction, regardless of who the customer was. So the only unique identifier or value was the customer ID. So if you could just iterate through every single customer ID, you can access everyone's Moonpig account. Apparently they're like a greeting card printer or something like that. So you see here, just customer ID over there, and then just the same. Obviously you don't have any comparison, but it was just the same basic auth header every time. I couldn't come up with a good title for this one, but I called it failure to restrict privileged functionality. So in the case where you have, say, a method or some sort of functionality that is privileged but unrestricted to lower privileged users, such as destroying the Death Star, that would be awful. Colloquial example: creating a new user account as not an admin or not a role that should have that. External authorities, such as like any kind of federation that you're doing, OpenID, or if you're doing authorization through OAuth. If any failure there, that chain could be bad. That could exacerbate any sort of discrepancy between what one authority thinks your role is and what another authority thinks your role is, or whatever the API might be. So I don't know if it's like a confused deputy problem or not. So LifeRay, is anyone familiar with LifeRay? It's like I think it's used often by like medical equipment and clinics and stuff. So in 2012, these two guys, Danilo Massa and Enrico Cinquini, discovered that LifeRay's JSON API had unrestricted access to this one particular method that would let you set an arbitrary account's OpenID identifier. So even if you're an unprivileged user, you hit, you call get user by ID just iteratively. It's just an integer, so you just iterate for each one, enumerate all the users, and then for each one, call get user role to then determine who's an admin, and then just call as an unprivileged user this update OpenID and just set anyone's OpenID to maybe the OpenID user that you control. So then you could set that on an admin, and then just often hit your OpenID provider, and then go back to the relying party, and be like, okay, now I'm an admin. Any questions? People have a question. I'm like way too fast.
So anybody can you can set up anything in OpenID service.
Yeah, so the example that they gave was go to like myopenid.com and create a random account. And then when you find one of these installations that's vulnerable, you go through this process, and then for admin Bob, just set update OpenID to Dan at myopenid.com. And then it'll be like, okay, and then you log in there, get redirected, and Bob's your uncle. No pun intended. So Bob. So I'm already like way ahead here. Oh yeah. Did PayPal ever fix that 2FA bypass?
Yeah.
Kind of. They closed the hole. They fixed the glitch.
But there's still another hole.
No, they basically just made it so that 2FA accounts don't work in mobile at all. I mean, they didn't really work before, but now they just don't return any of the information necessary to actually allow you to even get past step 0.5. So yeah, and it also broke a lot of merchants who were using that API. So like I think Etsy, Uber, Starbucks are three of the first three vendors that come to mind that will support PayPal. But if you were checking out using PayPal for any reason, it's like your account just doesn't work there either. So they didn't fix it, but the issue is gone. So some solutions, and a nod to Dan over there for mentioning some of these. I hate XML, it's horrible, but WSDL 2.0, if you're not familiar with web services definition language, it's ugly blobs of XML that you see when you're defining a web services interface. So originally it was for like SOAP-based interfaces, horrible XML ones, but 2.0 added in, removed a few things, but also added in support for describing RESTful services. So you describe what the arguments are to an input, their order, where the client should talk to, and this is just an example that I totally ripped off from W3. But yeah, you just see it's got this operation returns a list of books. Here are some elements that you will, here's an input, here's an expected output. And it'll describe things like you would expect, what the expected output should be. But I think a little bit better than WSDL is WADL, which is also, it's WSDL-like, it's still all horribly XML-based, but it's basically WSDL just for REST. So it'll describe resources that you will hit, the inputs, and any parameters to any of those inputs, and the expected responses, including the expected content type. So that might be nice to actually validate that you're not getting XML back when you expected JSON, or whatever, or you're getting text, and you don't have browsers that are assuming line types and stuff. This was submitted to W3C in 2009, but it's not going to be standardized, I guess. Sun submitted or something. And Apache CXF, the JAX-RS, the Java API for RESTful web services. For anyone who wants to do this, I feel bad for you because it's XML, but they support WADL for service definitions. And don't take this as an endorsement, but there's this thing called Swagger, and I totally missed the opportunity to put someone with swag walking around. This was originally by Wordnik, I guess, and now it's maintained by Reverb, or I don't know what their relationship is, but this is their open specifications, open source as well, an interface for defining and building RESTful APIs. I like to think of it as an IDL, interface definition language for REST. So it'll let you generate code, documentation. It builds a testing toolbox for you to go through and validate things yourself. And there's numerous libraries for pretty much every modern web AE language. So this is just an example. They're like hello world. So it defines like base path, which each endpoint is, what the operations that can be done on that are, what the types for each of those inputs are. So very similar to like WSDL, WADL, etc. One of the I like the way that you define these much more cleanly. And there's a really cool editor online as well. It's like editor.spider.io or something that lets you interactively use YAML to then build these. So if you wanted to abstract it even further, it'll help you generate your IDL that you then use to generate more stuff. So it also, what's also nice about it is it takes into account different various security, that's good, different security schemes. So HTTP-based auth, if you had just generic API keys, it also will do, supports, it understands OAuth 2. So the one thing that I will say, it's not panacea. It's not going to like solve all the problems. People still have to define nice interfaces, but when it generates clean code and it also has this testing sandbox, that'll at least give you an opportunity to kind of like make sure that inputs are what they are supposed to be and outputs are what they are supposed to be in a very nice, beautiful UI. So this is just the example of their like testing sandbox UI, and it's kind of washed out, but it's cool. It has like if it's a destructive operation, it will mark it as like red. So you know that is destructive. If it's something that modifies something but doesn't necessarily destroy it, it marks it kind of like yellow. And if it's just returns data, then they'll mark it as green. And they have they have like blue. I forget what that indicates. So it's kind of a cool way to just look at like schema for every object. You can adjust like parameters, and it's also nice, so if people are using your API, then they know what to expect. So yeah, so that's not the last slide. Yeah, I'm gonna get this slide. So it's not a new list. It's not exhaustive. I actually was only going to do this about the PayPal thing and just like blow that up into a big, like very technical discussion. But when I talked to some of the people running OWASP Cali, they were like, maybe something about API security in general. I was like, okay, sure, why not? So we barely scratched the surface here. I'm sure that this is not even remotely exhaustive. And of course, what's old is new again, all this has happened before, et cetera, et cetera. Yes?
So, coming from the security engineer perspective, I'm handed an API or a site to an API and say, go test it. Figure if it's insecure or not. What would be a framework that you would do to fuzz an API to see if you could break the universal functionality?
So that's a good question. I mean, there are obviously a lot of tools out there, Zap, Burp. There are, personally, I would probably end up writing something or using something like SOAP UI. In the case of something that's like SOAP-based, obviously SOAP UI, I don't think it's really REST-y, but something that would at least I could kind of walk through iteratively and just get a feel for that API. But ultimately, testing it would probably end up involving custom scripting. And I don't think it's not really a perfect science yet for testing like RESTful APIs. Yes, please.
Every time I need to test an API, it's always Burp and like the fuzz database, like all the strings from the fuzz database. Just testing REST inputs in the URL or wherever they're getting stuff in there. It's basic web testing.
Yeah. You had a question in front, sir?
process of the API definition. So it goes back to stupid proofing and developers and keeping the cost of testing reasonable.
Yeah, I mean, obviously there are plenty of commercial solutions that will do things like a little more advanced than some free or cheaper tools, but I think in a perfect world, having some sort of really well-defined schema or interface early on, like Swagger or Waddle or Whistle 2 or something that you can then feed into automated tools later to ensure that inputs and inputs go in the way they're not supposed to, and outputs hopefully don't come out when they're not supposed to. But yeah, there's not really a perfect answer for automated testing of some of that stuff right now. I am to understand that some things are being developed around that as this all plays out. That's it.
Yes. You mentioned that static API keys are a bad idea. What's a better idea?
So I really probably meant more static credentials. When I listed that bullet point as static API keys or shared API keys are used, wasn't really meant to be like, don't do it. I think the issue there is probably more going to be around like, if it's a quota, like you're measured on a quota, someone abusing that shared API key could cause problems because then suddenly no one can use your app or talk to that service. That's real. There have been some, I don't know, attempts to kind of, I don't know, maybe someone has a better answer for this. Some attempts to have a shared ID or some sort of token that's used again and again, but have it like refreshed or changed or exchanged every so often. I think like OWASP, for instance, tries to do it has a refresh token. I don't know if anyone has solved that problem yet. If they have, we should talk about it. Yes.
Do you have any recommendations for API monitoring for malicious activity?
I do not. Aside from like watching logs. I mean, there are plenty of tools out there like Elasticsearch, Logstash, Kibana, that whole elk stack that are pretty powerful. That will at least you can start to measure when, especially graphically with Kibana, when requests spike up or map them to a particular like do GeoIP. Well, now all of a sudden we're getting requests from a country we never got them from before. So what? Right. So I mean that would be. It's probably going to be kind of roll your own or look at what other people have done around that. Questions? Oh,
Yeah, on the defensive side, have you seen anything? I know F5 supports JSON in their ASM module, but have you seen any other WAF or IDS type solutions that are effective JSON configuration?
Nothing. I haven't dealt with anything that's specific to that. It's usually like, oh well, here's a rule match, like pattern match on that. Oh, it looks kind of like JSON. So, but I personally haven't interacted with anything that's really supports JSON specifically. Has anyone else? Has anyone done that?
Only thing I've seen is F5.
Well, cool. Well, I know I ended a little early. That's fine. That means you can just sit here and I can regale you with tales of mischief. But thanks for coming. I know I went fast. If you have any questions outside of here, that's my personal address, that's my work address, and that's my Twitter ID. And hello to all these people down the bottom. So, thanks. I would say that it's all kind of and as we were saying, testing, finding when there's a skin
REST interface.
like that. But
We've already asked about APIs.
square peg round kind of thing.
Or docs, like that.
That's something.
I love APIs. So, API OAuth 2. Do you check to make sure that the session has a C-cert token? Okay, because it does, you can use it for the radio apps, and you can make someone use it so that.
Yeah.
Yeah.
So it has support to a lot.
Yeah. There's all sorts of stuff.
So you have it,
Test the code that you have first. So look at it, this, just check that. But if you want, it's in
Yeah,
okay.
it's hard to
If you redact them,
but then they take
security session for a while back. Security. That's amazing.
try to get a hold of it. That's not all I will check out.